Okay, welcome back to comparative pie charts, and today we're looking at the short method now. So earlier on I showed you the long method, and if you haven't seen the long method, I'll probably go into more details about how comparative pie charts work. But if you didn't, I'm gonna go into detail again pretty quickly. So pie charts, just normal pie charts that you do in maths GCSE, you can use to compare proportions of things. So you can say a higher proportion of travel agents went to North America in comparison to the proportion of teachers that went to North America. So proportion is fine. You cannot say a higher number of travel agents went to North America than teachers, because pie charts, we don't know the numbers, we just know the proportions. However, when we go to comparative pie charts, the area of a comparative pie chart is proportional to the total frequency. So if I have that is not a good circle. If I have a pie chart for teachers like this, and I have a pie chart for travel agents like this, if we know they are comparative pie charts, then we know the sample size for the travel agents. Let me just write that so it's clear. Travel agents is bigger than the sample size for teachers, because the area of your comparative pie chart is proportional to the total frequency. So in my first video, I went on to show you how it worked. So I'm going to do the long method quickly, again, just to reiterate how it works. So if I have given myself a radius of 6 for my teachers, then we know the area for teachers, using the area of a circle, is pi times 6 squared, 36 pi. And we know travel agents, we have 40 out of 60 travel agents, because 40 were travel agents, 60 were teachers, so 40 out of 60. That is the proportion. So we can find the area by scaling it using that scale factor over here. So 40 out of 60 times by 36 pi. And if you type that in, 40 out of 60 is the same as 2/3. If you times that by 36 pi, you get an area of 24 pi for your travel agents. But for most questions, what they really want to know is what is the radius. So we know pi r squared is equal to 24 pi. So r squared equals 24, because we can cancel out the pi on both sides. So your r is going to be the square root of 24, which is equal to 4.90 centimeters to 3 significant figures, or 2 decimal places. So that was the long method, which is it's not really long, but like there's a quicker method. So here's the method I want to use. So using my proportions, there is a lovely formula, which is your radius 1 over radius 2 is equal to the square root of your frequency 1 divided by the square root of your frequency number 2. So you can use this method for short, or you can use this method if you prefer the longer method. Both are okay. This video is going to focus on using this method, whereas the video I've posted before focuses on the longer method, but still efficient. So let's think. So we know our formula is R1 over R2 equals the square root of your frequency 1 over frequency 2, where R are your radius and F is your frequency. Oh my god, why am I writing it wrong? R1. Okay. So we're given a radius of 7 for adults. And we know the frequency for adults is 90. So that's going to be our R1. And our frequency, so that's going to be our F1. We know our frequency for children, so that's going to be our F2. And we don't know what the radius is. So let's use our formula. R1, which is 7 over R2, what we're trying to find out, equals the square root of F1, so the square root of 90, over the square root of F2, which is 60. So all you need to do is some rearranging. So I'm going to get R2 is equal to 7 divided by the square root of 90 over the square root of 60. And you can figure that out through GCSE rearranging formulae. And if I do that, 7 divided by square root of 90 over the square root of 60, I get a radius of 5.72 centimeters. So let's do another question. So we've got 80 adults and 110 children. So we've got our frequency 1, our frequency 2, and we've been given a radius of 7. So we have our R1 for adults, and we're trying to find the radius for children. So we have R1 over R2 equals the square root of F1 over the square root of F2. And then now to find your R2, you just do some rearranging. So I get R2 equals 7 divided by the square root of 80 over the square root of, sorry, I meant to write 110. Square root of 110. So you type that in, 7 divided by the square root of 80 over 110. We get 8.21 centimeters. Okay, one more just for luck. R1 over R2 equals the square root of F1 over the square root of F2. So we've got our F1, our frequency 1, but for the adults. We've got our F2 for the 120 children. And we have our area for adults, so that's going to be our R1. So R1 over R2 equals the square root of F1 over the square root of F2. And then you do the rearranging, so you get 7 equals, not 7, sorry, R2 equals 7 divided by the square root of 90 over the square root of 120. If I do that, I get 8.08 centimeters. So that is your choice. You can use the long method or you can use the short method. I personally prefer the short method, but if you're not good at remembering formulae, then go for the long method. It's a personal choice.